switch now to naming ionic compounds. Ionic compounds consist of ions. So the first thing we need to do is we need to learn how to name ions. Ions are either going to be positively charged or negatively charged due to an imbalance of electrons. So if we have cations, these are positive charge. If we have anions, they're negative charge. And so ionic compounds, ionic compounds are, you write the cation name, space, and then the anion name. And so we just have to figure out what the cation names are and the anion names are. And so we're going to take a look at the monatomic ions first. We're going to look at the monatomic ions, which are going to be just single atom ions. And there's a certain pattern in the periodic table that we can use to help us learn the monatomic ions. And so we have the cations, which are going to be like sodium with a positive charge. A sodium with a positive charge is called the sodium ion. Whereas sodium with no charge, this is called sodium or elemental sodium or sodium metal. And so we need to be able to differentiate between sodium ion and sodium, the element here. That would be the sodium would have a metallic lattice, so this would be the empirical formula for that. Let's look at some other examples. Sometimes we have situations like this come up. And so what should we call these? I have an Fe with a 2+ charge. Here I have an Fe with a 3+ charge. And so these have positive charge. The positive charge is a result of losing some electrons. This one's lost 2 electrons, this one's lost 3 electrons, so we have an imbalance of protons. There are not enough electrons to neutralize that charge. And so should I call that iron? No, because if I call that iron, I might be thinking about elemental iron or iron metal. I should call it iron ion, but if I call it iron ion, then I get confused because there are 2 iron ions available. There's an iron ion with a 2+ and an iron ion with a 3+. Unlike sodium, in sodium there's only 1 ion, and that's sodium with a 1+ charge. And so I have to be able to differentiate these two, and therefore we come up with another system here. We're going to call this iron, open parentheses, Roman numeral 2, close parentheses. This is all one word. And so this would be the iron 2 ion. This would be the iron 3 ion, where the Roman numeral indicates the charge. So iron 2 and iron 3 ion. There's an old system. In the old system, this is called ferrous, from ferrium. Ferrium, I think, is Latin name for iron. And so this is ferrous. The aus refers to lower charge. And the bottom one's called ferric. The ic refers to higher charge. So ferrous, ferric. This is higher. And so 2 different ways we can differentiate these two. We could use the Roman numeral, or we could use these kind of Latin-based names here. Now, when we look at the anions are going to have a negative charge rather than a positive charge. So, for example, chlorine. This is chlorine here. But if we put a negative charge there, that means this chlorine got an extra electron. If it gets an extra electron, then it has excess negative charge, which we show by this. So chlorine has a -1 charge. We don't call it chlorine anymore. Okay. We don't call it the chlorine ion, because chlorine ion would usually refer to a positive charge. We're going to call this chloride. And so if we have a monatomic anion, it's going to have the monatomic anion will typically have the I ending. I ending. And so whenever we see the I ending, that usually refers to monatomic anion, but not always, because there are some anions that end in I that are not monatomic. So let me just write some exceptions here. Except for things like this, OH minus. OH minus is hydroxide. So that's what we call polyatomic. That's hydroxide. What other polyatomics end in ide? Another polyatomic that ends in ide would be O2 2 minus. O2 2 minus, this is called peroxide. And then we have Cn minus. Cn minus, this is cyanide. How about something like this? H minus. What is H minus? Well, that's monatomic, and so we would call it, would be called hydronide. Hydrogenide. The hydrogenide is a little bit cumbersome. And so this is called hydride. And so sometimes people get hydride and hydroxide mixed up. Hydride is a monatomic anion, hydroxide is a polyatomic. This is a polyatomic anion. But typically when we have the ide ending, it's just monatomic, chloride, bromide, iodide, etc., oxide. There are some polyatomic cations too. Let's take a look at these. Sorry, the order got mixed up here. Polyatomic cations would be things like Hg2 2+. Hg2 2+. This is called mercury 1, Roman numeral 1 ion. And so where does the 1 come from? Because it looks like there's a 2 here and a 2 here, so shouldn't it be mercury 2? Or maybe mercury 4? Where does that 1 come from? It turns out this 1 comes from the charge. If you have 2 mercury atoms for combined charge of 2+, that means each mercury must be individually 1+. So 2 the atom to 2+. So this is a polyatomic. There aren't that many polyatomic cations. This is another polyatomic cation here, ammonium. All right, so let's go back to the monatomics and take a look at the periodic table here. If you look at the periodic table, the first column, which we call the alkali metals, these are all +1, like sodium, potassium, lithium. The second column in the periodic table is +2. The third column in the periodic table is +3. And then after this, these are all variable charge. Here. And then when we hit the bigger columns like this again, then this one's going to be +3 here. This next one will be +4, and then +5. I'll put that in parentheses here, and then +6, then +7, and then there's no +8. These are the noble gases. The noble gases are stable. They don't like to form ions. In other words, they don't like to gain or lose electrons. And so this is the scheme. Now you look, there's 2 +3s. Do you see that? 2 +3s here. And so we have different numbering schemes for this. One numbering scheme is like this, 1, 2, and then there's 10 here. This would be 13, 14, 15, 16, 17, 18 columns. Another scheme is like this. We call this Roman numeral 1A. This is 2A. And then we jump all the way over here. This is 3A, 3A, 4A, 5A, 6A, 7A, and then 8A. The A's refer to what we call main group elements. And so the A block, there are 2 A blocks. This one on the left and the one on the right. And so that's group 3A there. This would be group 3B. The B group, these are the transition elements. So we could see that here in a more detailed periodic table. Let's take a look. If I have that still up, too many tabs here. So here I could see both numbering schemes here. Although this kind of got screwed up. That's group 1 or Roman numeral 1A, Roman numeral 2A. I don't know what all this other junk here is. It's 2A. I think these are typos here. And so we'll jump from this 2A all the way to this 3A, 4A, 5A, etc. And then we have the B's here. If you look, this is 3B, 4B, 5B, 6B, 7B, and then 8B is kind of weird. And then it goes back to 1B, 2B. This numbering scheme has a lot to do with the properties of these things. Basically what this is this. These are all fixed charge. So the monatomic ones here, this is group 1, all +1. Group 2 is +2. Group 3B is +3. Group 3A is +3. Now when we get to +4 is a hard charge to get. And so it turns out these are either +4 or -4. Let me put that in parentheses here. And this could be +5 or -3. -3 is okay. This is +6 or -2. This is +7 or -1. And these are 0. They shouldn't have any charge. Those are stable. And so these are fixed charge too, you know, as far as the anions go. And as far as the cations go, these are pretty well fixed here. And this is a bit too many to lose. You know, when we go to +4, +5, +6, +7, it gets more and more difficult to lose that many electrons or gain this many. And so these numbers are useful, but we'll see later how to use them. So these are the common things that we're going to see. Now the variable charge is funny because the variable charge doesn't end here. The variable charge creeps into the main block. Let me show you that here. So the variable charge begins here at group 4, and then it continues on. And you think it stops here, but it doesn't. It creeps in here. And so some of these elements down here, which are called heavy metals, or all these are heavy metals, but these here, like lead, of mercury. Those are also variable charge in this region. And so the variable charge kind of overlaps here with the main group. So let me cut that in here. And so if you have an element in this area, then chances are it has more than one charge. You have to be careful. We also have to be careful because here, there's a little island of fixed charge ions here in the variable charge region. And this little island, I better not include those in the variable charge because these are fixed charge, so I need to go like this. Then it's okay. And this little island of fixed charge are zinc, which is always 2+, cadmium, which is always 2+, and silver, which is always +1. So these are fixed charge here. And so just this region here will be variable charge. Now what is the charge? Well, we'll have to figure that out. So let's look at the ions, naming some of these. All right, let's name these. Well, one, there's a charge, so it's an ion. This is negative charge, so it's an anion or cation? Anion. And when we have an anion, we have to change the ending. So what is the name of this? Bromide. Fixed charge -1. Bromide's here. So as an anion, it's -1. As a cation, it would be closer to +7. See that. What's this one? Would this one be, well, this is a cation. It's actually a 2+, so the positive charge got omitted off there. And so is this is the element barium. So is this barium Roman numeral 2 or just barium? Well, we got to look, is it fixed charge or variable charge? Well, barium's in this column, so it's fixed charge. So that would just be barium ion. So we have bromide and barium. Take a look. Bromide and barium. Bromide, you don't really need this word. And so oftentimes we'll just leave this off. Because if you see bromide, it's got to be an ion. So you don't need ion here. But for barium, we do need ion, because if you left off ion, then we don't know if you're talking about metallic barium or just the cation. All right, oops, I jumped ahead. The formulas for potassium. What is the potassium ion? So we're going to find, where's potassium on the periodic table? It's in the first column here, so it's what we call group 1. And they're always +1. And so the potassium ion is going to be, what's the symbol for potassium? K. It would be K +1. And then we look for fluoride. Well, this tells me it's got to be negative fluoride. Fluorine occurs in group 17 or 7, and that charge, a negative charge, will be -1. Fluoride is F-. K+ then. Here is the variable charge. Look at the bottom, Fe2+. It is known as, Fe2+ is known as iron 2, all one word, iron 2 ion. In this case, we don't need ion because if we have a Roman numeral 2 here, means that it's an ion. And it can't be anything else. And the other charge that's commonly observed for iron is iron 3. Here's a special case. Mercury forms diatomic ions. These are polyatomic or diatomic, in this case, 2 atoms. We have 2 atoms of mercury bonded together with a total charge of 2+. It's called mercury 1 each. each of the single mercuries has a +1 charge, and we have to combine 2 of those. All right, what's the name of Mn2 plus and Mn3 plus? Well, what's the name of Mn? Is that magnesium or manganese? That's manganese. Is it variable charge or fixed charge? Variable. So if it's variable charge, we need a Roman numeral. If it's fixed charge, we don't need a Roman numeral. And since it's variable, we got to call the first one manganese, Roman numeral 2. The second one would be called manganese 3. So manganese 2, manganese 3. Got here. First one manganese 2 ion, second one manganese 3. Again, this ion's redundant because if we have a Roman numeral, it's got to be an ion. The formulas for nickel 2 ion and nickel 3 ion. Nickel 2 is Ni with what charge? 2 plus, and nickel 3 is Ni with a 3 plus charge. So it's nickel 2, nickel 3. So these are the monatomics, and now we're going to move on to the polyatomics. And I already talked about a couple of polyatomics, but we're going to look at all the polyatomics now. So the polyatomics are going to have more than one atom. So the first set are the polyatomic cations. There aren't that many. Just to reiterate, the polyatomic cations are going to be NH4. Did I talk about this one? This one is called the ammonium ion, and we just memorize it, ammonium. Well, how do you memorize ammonium? One thing that I did as a student was I did flashcards. So I tried to memorize them using flashcards. But when it came to the exam, I had a hard time writing it down. You know, I thought I knew them pretty well from the flashcards, but I had to write down the formula on the test, and I got confused. And so I gave up on flashcards. You know what I did instead? Like if I wanted to memorize ammonium, I just wrote it over and over again. I would write ammonium like 50 to 100 times. If I write it 50 or 100 times in a row, then it goes into like my motor memory. It goes into motor memory. It's like riding a bicycle. You know, you've written it down so many times, and if somebody says ammonium, you just write it NH4 plus, NH4 plus, NH4 plus, right? And so you never forget it because it's like I said, riding a bicycle. You aren't going to forget it if it goes into your motor memory, but it takes some time to get into your motor memory. You know, it's like learning to ride the bicycle. It does take some time initially. Versus flashcards. You know, flashcards is watching a video of somebody riding a bicycle over and over again. And watch a video of somebody riding over and over again, and you don't get that motor memory in there. So I recommend just writing it repeatedly. Is one way of doing it. So that's ammonium. Do you know another polyatomic cation? The other polyatomic cation that we worry about is Hg2 2+, which we call what? Mercury 2? Or mercury, well, it looks like 2 because I got a 2 here and I got a 2 here, but it's actually mercury 1 because each of these atoms that are bonded together is plus. So it gives us a net charge of +2. And that's it. These are the polyatomic cations. And then we have the monatomic cations. Monatomic cations are pretty easy. It's either fixed charge or variable charge. And we don't change the name. We just leave the name as is. And then we have the anions. The anions are a bit more complicated because we have 3 variations of anions. We have the anions that end in IDE. We have the anions that end in ATE. And we have the anions that end in ITE. We have the ides, the aids, and the ites. The ides, whenever you see an ide, you automatically assume it's going to be monatomic, right? Except for certain polyatomic ides. What were the polyatomic ides that we should remember? You know, normally it's like chloride, Cl minus, fluoride, F minus, oxide. You know what the charge on oxide is? What group is oxide in? Oxide would be oxygenide, but we don't call it oxygenide. Oxide. It's O2 minus. And so those are monatomic. What are the polyatomic ions that we should remember? A big one is this. What was this one? Hydroxide. This one? O2, 2 minus. This one is peroxide, Cn minus. So cyanide. So we could have more. So those are the ides. This is just raw memorization. I'm just going to memorize it. But, you know, raw memorization, you either, you know, with raw memorization, you either know it or you don't know it. And it's a lot of work. And so what we try to do is we try to minimize the amount of memorization we have to do by looking for patterns. If we can find some patterns, we might not have to do that. And so that comes with the eights. The ides, you just have to memorize them. There's no other way around it, unless you come up with some kind of tricky mnemonic or pattern to help you memorize it. But eights, there are two. There's the ones we can get from a pattern on the periodic table, and there's others that we just have to use raw memorization. All right, let's take a look at the ones that we can get from the periodic table. The ones that we can get off the periodic table, we'll start with boron. What group is boron in? B, group. You probably can't see the periodic table so well, but it's in group 13 or 3. 3A. 13 or 3A. And we have to learn boron forms the ion borate. And borate is BO3 minus. And so you have to memorize that. And so when we look at the periodic table pattern, then we have the borate series. Okay, so for the borate series, it's going to go like this. What's next to boron? Carbon. And we have carbonate. Carbonate has this. Carbonate. It's NO3, 2 minus. And then next to carbon is nitrogen. Oops, this borate, I made a mistake here. Borate is BO3, 3 minus. And carbonate is CO3, 2 minus. And so can you tell me what nitrate is? Let's take a guess what nitrate is. Do you see a pattern? Yeah, and you would be right. I know 3 minus. Maybe you had it memorized. Did you have it memorized, or do you just see the pattern?
Nitrate with nitrite.
Okay. Okay, then we have oxygen. Oxygen, there's no 8 for that. And then we have fluorine. Okay, there's an ion called fluorate. Tell me its formula. Just take a guess. Fluorate. Well, this one might be hard. Take a guess how many oxygens it would have. 3? You'd be right. And then the charge, I'll tell you what the charge is. The charge is minus. And so the fluorate is FO3 minus. And below fluorine is chlorine. Chlorine would form chlorate. And chlorate would have the formula, what? ClO3 minus. Good. And then below chlorine is bromine. And what would bromine be? Br, how many oxygens? 3 oxygens. What's the charge? Negative. And finally, ID. Tell me about ID. IO3 minus, and then what would it be called? Iodate. All right, so this is the borate series. The borate series, all we have to do is memorize one. Which one do we memorize? We memorize BO3 3 minus. And then do you have to memorize all the others? So if you're doing this flashcards, you know, you could have one flashcard and then memorize the pattern, or you could have 1, 2, 3, 4, 5, 6, 7 flashcards. What would you rather do? It's up to you. You can do whatever you want, but you know, my personal preference is one. Even though that's my personal preference, a lot of people say, you know what, this is not in the book, this is too confusing, I don't want to deal with it. And so they just make flashcards, which is perfectly fine. Flashcards will write it down, but you're going to have to memorize it. But the problem is this. The problem is that if you have a pattern, you're in a much more powerful position than if you're just doing raw memorization. If you're doing raw memorization, then if it's not on your list of things to memorize, then you don't know it, right? But if you have a pattern, you might be able to figure it out. And so the other series is the silicate series. Silicate is SiO4 4 minus. Call it the silicate series. Silicon is right below carbon. And what group is this? Group 4 or 14. And so SiO4 4 minus is what we call silicate. And that's where we're going to start in this series. And so next to silicon is what element? Phosphorus. And so tell me what phosphate is. Phosphate. What do you guess phosphate is? Yeah, you'd be right. PO4 3 minus is phosphate. And then next to phosphorus is sulfur. What do you think sulfate is? SO4 2 minus is correct. And then we run into the other series. We're going to separate those two series. Do that. And so the example, and your book does this as well, your book is going to look for patterns too. An example of things that you might be able to predict. If you were just doing raw memorization and arsenate was not on your list, arsenate, yes, arsenic is below phosphorus. You might go, well, you know, that wasn't on my list, therefore I didn't memorize it. Therefore I have no idea what arsenate is. Or if you know the pattern, you might be able to figure out what arsenate is. And so, can you figure out what arsenate is? What would you? ASO5? That looks good because 3, 4, 5, but this is a bit tricky. This is a bit tricky because what happened here? Did we go 3, 4, 5? No, and so the pattern is a bit more complicated. Do you know what it is? It's not 5, it's going to be 4. It's going to be ASO4 and the charge 3 minus. And so if you know that, if you know this, then this shouldn't be hard. What is selenate? Selenium is below sulfur. And so selenate should be SeO4 2 minus. That's correct. What do you think germinate is? Germinate's below silicon. Knowing this pattern, you'd say germinate is GeO, how many O's? GeO4 charge 4 minus. And so that's the pattern. And so this is a pattern that we can use to help us decrease the amount of memorization. But with that said, not everything fits this pattern. And so some of the 8s we just have to memorize. And what are those 8s that we have to memorize? The 8s that we have to memorize are things like this. So these are raw memorization. And so write flashcards or write these down repeatedly. We have CrO4 2 minus. CrO4 2 minus is called chromate. And then we have Cr2O7 2 minus. This is called dichromate. There are other little tricks that can help you remember these. But we have got chromate, we got dichromate. What other 8s we have? You have C2O4 2 minus. This is a chromium, this is a carbon. C2O4 2 minus is called oxalate. Oxalate. MnO4 minus 1. MnO4 minus is called permanganate. Permanganate. Etc. So those don't fit this periodic table pattern. And those are just best memorized. This chapter has a lot of memorization. All right, those are the 8s. And then we have the ites. The ites have one less oxygen, one less O than the 8s, same charge. So that would be something like NO2 minus. NO2 minus looks like this. Looks like nitrate, but it has one less oxygen, same charge. And so we don't call it nitrate, we call it nitrite. So I don't have to memorize nitrite. If I have nitrate memorized, or if I know what nitrate is, or if I can figure it out, then I can figure out what nitrite is. Then I have some more others that are going to kind of be similar. So for example, I have ones that are the per-8s. Per-8 means that we have one more oxygen than 8. Same charge. So for example, ClO4 minus. Well, ClO4 minus, if I look at it, it looks like ClO3 minus. Right? ClO3 minus is chlorate. This has one more oxygen, same charge, therefore this is going to be perchlorate. Perchlorate. And then I have another one, which is the hypo prefix and the ite suffix, hypoite. And so this is one less oxygen than the ite, same charge. So let's go to hypochlorite. What is the formula for hypochlorite? Somebody tell me the formula for hypochlorite? Well, it's going to be Cl. Well, one thing we might want to do is just write out the series. So, for example, we know what chlorate is. What is chlorate? ClO3.
3 minus. Then if we know what chlorate is, then we know what chloride is. What is chloride? ClO2 minus. And we can figure out what perchlorate is. What is perchlorate? ClO4 minus. And then that leaves us with hypochlorite. What is hypochlorite? ClO minus. And so this would be the series from perchlorate to hypochlorite. And so if we know one, we can figure out all the others. So this saves us making flashcards here. So if you know patterns, then you can save yourself some work and memorization. You don't have to memorize it. And so what we're going to do is we're going to do some naming of compounds and writing formulas for compounds. So let's look at ionic compounds next. Okay, so we talked about the names of the ions. The names of the ionic compounds and the formulas are going to be pretty straightforward. The names and formulas always start with the cation. And so typically we'll have the cation first and then the anion. The cation name, anion name. Or cation formula, anion formula. So here we're writing formulas for ammonium bromide. And it's a little bit more complex. Like, for example, ammonium. When I look at the name, it's ammonium bromide. And the way ionic compounds are written, we have the cation first, and then the anion next. And then we figure out what is the formula for the cation, ammonium. The formula for the cation ammonium is NH4 charged plus. And then bromide, what's the formula for bromide? Br2. Br2 would be for elemental bromine, but not the anion. The anion is not going to be Br2. The anion is actually going to be Br single with a negative charge. So that would be bromide. And then what we have to do is we have to charge balance these. Charge balance just means the total positive must equal the total negative. So the total positive is +1, total negative is -1, so it balances positive and -1. And so the formula is NH4Br. Okay, next we're going to do ammonium sulfide. Ammonium sulfide. Ammonium sulfide is just a little bit more complex. Ammonium is the same, NH4 plus, but sulfide is, well, the I tells me it's monatomic. What is the formula for sulfide? It's going to be S, and the charge, 2, positive or minus? Minus. When we look at this, this is not charge balance. And so what we have to do is we have to charge balance this. And so I have 2 negatives, that means I'm going to need more positive. And so I'll throw in another ammonium, and then that works out. I'll just have NH4, 2 of these, and a sulfide. Does that look right? No, because if I look at this is NH42, it's not NH42, it's NH4 2 times and a sulfide. So that's what this means here, NH42. So that would be the formula for ammonium sulfide. We are not creating an ion, we're creating a compound, and compounds have to be electrically neutral. So that's what they're showing here. You know, it's a 1-to-1, +1, -1. Whereas sulfide, we need 2-to-1, 2 ammoniums to cancel out the 2 minus sulfide. So it's NH4 2S. Write the formulas of aluminum oxide and barium nitride. So, aluminum oxide. Aluminum, fixed charge or variable charge? And what is the charge on aluminum? Positive what? +3. Oxide. Oxide is monatomic. It's not one of the polyatomics that we had to memorize, like hydroxide. Even though oxide and hydroxide sometimes are confused, they're different. And so oxide's monatomic. We just have to figure out the charge. What is this charge on oxygen? 2 positive or 2 minus? Now, if you look at it, the charges don't balance. The total positive charge must equal the total negative charge. So we got more positive charge, so let's add a negative. Now is it balanced? Now we have too much negative. If we have too much negative, let's add a positive. Now is it balanced? Now we have too much positive, not enough negative, so let's add a negative. Now is it balanced? Yes. And so the formula for this is we need 2 aluminums for every 3 oxides. And so this is Al2O3. And so we call this aluminum oxide, but we would not call this dialuminum trioxide. Why? And so we don't use this name. We just use aluminum oxide because dialuminum trioxide would be for binary. Well, is this binary? Actually, this is binary. So maybe we should use it. But it's for binary molecular. Is this molecular? No, because molecular consists of all nonmetals. Ionic compounds consist of a metal and a nonmetal. We have a metal and a nonmetal. When we have a metal and a nonmetal, then typically it's not molecular. It's ionic. Ionic, not molecular. And so for ionic compounds, this is the way we name it. We just name it aluminum oxide. Let's finish the last one, barium nitride. And so what's the barium ion look like? Ba2+, we saw that earlier. But what is nitride? Yeah, this is barium nitride. It's going to be N3 minus, is correct. Because we have too much negatives, so we'll add a positive. Now we have too much positives, so we'll add a negative. And too much negative, we'll add another positive. And are we balanced? Yeah. And so this is Ba3 and 2. This is called barium nitride. No, it's not called tribarium dinitride because it's ionic, not molecular. Okay? All right, so I'm going to stop here.